Let's do another example of graphing absolute value functions written y is equal to a, absolute value x minus h plus k. Let's start with a fairly simple example. Y is equal to minus absolute value of x plus 6. The first thing that you're going to do is you're going to find the vertex. The thing you have to realize here is this is actually y is equal to minus 1 absolute value x plus 0 plus 6. So we don't write it there, but there really is a 0 there, so that means the vertex is going to be 0, 6. And the 6, since it's a k, does not change signs. The second thing you're going to do is you're going to ask yourself, does this open up or down? A is a minus 1, so this is going to open down. And next, is this narrow or wide? It's going to be neither, because the absolute value of A is equal to the absolute value of minus 1, which is 1. So this is going to be, we can call it, say this is like y equals absolute value of x. So the only thing that you need to do now is you need to do a table of values. Put x here and y here. Put the vertex in the middle, 0, 6. And what you're going to do is you're going to choose two values of x, which are, one of which is larger than the x value of the vertex. Let's choose 2. And the other one, which is more negative, let's choose minus 2. It doesn't matter which x's you choose, but if you choose them so they're equal distance, positive and negative, from the x value of the vertex, then these two y's will be the same as well. So now you just plug these in. Let's plug in x equals 2 first. And you get y is equal to minus absolute value of 2 plus 6. Remember, you do what's inside the parentheses first, so that's 2, and then you do absolute value, so that's a positive 2, and that's minus 2 plus. Remember, this is a minus 1, so literally that's minus 1 times a positive 2, so that's minus 2 plus 6, or 4. Now let's plug in x equals minus 2. There you get y is equal to minus absolute value of minus 2 plus 6. Be real careful here. Most people know this, that they often make a mistake. Absolute value of minus 2 is a positive 2, but then it's minus 1 times a positive 2. So that's a minus 2 plus 6, so that's going to be 4 as well. After that, you just graph it. You just graph the vertex, and the 2 points, and connect the dots. So in this case, let's draw our xy graph. The vertex here is 0, 6. I like to put a little v there to remind myself that it's the vertex. The 2 points we chose were minus 2 and 4. Minus 2, 1, 2, 3, 4. And 2 and 4. 1, 2, 1, 2, 3, 4. And you simply connect the dots. It kind of helps you because you already know that this opens down, and you know that this is neither narrow or wide. In other words, it's like y equals x squared. And that's your graph. Y is equal to minus absolute value of x plus 6. And let's do another real quick example. Let's graph y is equal to 3/2 absolute value of x plus 6. In this case, we want to find the vertex first, right? The vertex here is hk. Well, h is here, but it changes sign, so it's a minus 6. So what's k? Well, there's not a k here. If you want to, you could write a k. That's the same as plus 0, so it's minus 6, 0. Does this open up or down? Let's look. The a is 3/2. 3/2 is greater than 0, so that means it opens up. And the next step is this narrow or wide. Let's think. The absolute value of 3/2 is equal to 3/2. And the rule is if the absolute value of a is greater than 1, then it's wide, so that it's narrow. And absolute value of a is between 0 and 1, then it's going to be y. Well, 3/2 is greater than 1, so then that's going to be narrow. You basically know what it looks like now, right? And if it's a multiple choice test, you might be able to stop here. Minus 6, 0 is about there. You know it opens up, and you know it's narrow, so you know it's going to look something like that. If you want to do a better graph than that, then what you would do is you would just do a table of values. Let's actually change. Let's go to the next page and do a table of values. In this case, you know the vertex is minus 6, 0. Put the vertex in the middle. Minus 6, 0. Choose some number which is more positive than minus 6. I'm going to choose minus 2. And one number that's more negative. Now this distance here is 4, so I'm going to go 4 back. That's minus 10. You don't have to do that, but if you do that, then the y's will be the same. It's also a nice way to check yourself. I'm going to plug in minus 10, so I get x is equal to minus 10. Y is equal to 3/2 minus 10 plus 6 plus 0. So it's 3/2. Do what's inside the parentheses, or in this case, the absolute value signs first. That's minus 4. You can drop the plus 0. Absolute value of minus 4 is simply 4. 3/2 times 4. You're going to multiply, so that's 4 over 1. So that's 12 over 2, or 6. Now, if you got a fraction, what you could do is go back and change the x values that you chose so you wouldn't get a fraction. In this case, we don't. Now you're going to plug in, oops, this goes here actually. Now I'll plug in x equals minus 2. It's actually going to be the same. That's why it was confusing. Y is equal to 3/2 minus 2 plus 6. Do what's inside the absolute value first. That's absolute value 4. 3/2. This is why they're the same, right? Here we had absolute value of minus 4. Here we have absolute value of 4. That's the same. 3/2 times 4, which is 12 divided by 2, which is just 6 again. The next step you would do is you would simply use some graph paper and plot these points, and then you're done. Let's do that real quick. The vertex is going to be minus 6, 0. Minus 6, 0, that's the vertex. We plotted the point minus 2, 6. Minus 2 and 6. And minus 10. 6, 7, 8, 9, 10, and 6. Then simply draw a line. This is the graph of y is equal to 3/2, absolute value of x plus 6. If you want to, you can put a plus 0 there to remind yourself that k is 0. Let's see, opens up. It's a little bit wider than x squared. A little bit narrower than x squared because of the 3/2. Vertex is 6. That's right. That's how you graph absolute value functions written in vertex form.